Good morning, everybody, and thank you guys for joining us today. I am Stephanie McCallard from the DATAMARK team, and I'm going to be the moderator for today's session. I'd like to introduce today's presenters, Annie Cahill and Becca Mangan. Annie has many years of experience with public safety and GIS workflows, the full suite of Esri products, and enterprise and relational database management systems. She has experience working with numerous states on NG9-1-1 and GIS-related projects, and she collaborates with the technical team members on analyses, standards, development, and best practices and other outreach. Becca has over 6 years of experience in the GIS industry with well-rounded knowledge of GIS data creation, database maintenance, statistical analyses, and designing workflows. She also has a strong background in GIS data collection and maintenance. Her understanding of data allows her to assist with any technical support that may be needed. And with that, I'm going to hand the mic over to Annie and Becca to start the presentation.
Thank you, Steph. And Steph, you could have just said that I learned on ARC Info, and that would give people a good indication of how old I am and how long I've been in GIS. So
yeah,
anyway.
Can't relate there, so.
So Becca, why don't you go ahead and share, unless you're doing that already.
I am setting up right now. Let me make sure I share the right one. We've all been there, right?
Oh, yeah.
All right. We able to see?
Looks great.
All right, kick her off.
Okay. So today we're going to discuss the top issues that we see in NG9-1-1 data remediation. So just to give you a little bit of an overview, if you've never been to one of our webinars before, or you're not familiar with our company, we really specialize in public safety GIS, and more specifically, we work with people who have a lot of issues with their data, or they just are concerned about getting it up to speed for NG9-1-1. The data can come to us in really good shape. Sometimes it's not. And we take care of that if that's part of the project scope. So we call that data remediation. Sometimes it's called data cleanup. But basically what this involves is a full assessment of the client's data, and then basically doing an assessment to determine where the issues are, what we need to fix. We work with the client to understand why data is being maintained a specific way, and then we take certain measures to get that data corrected. So let's go to the next slide. And we will have some polling questions, and you've already met us, but we will have some polling questions throughout the presentation, so you guys can just type your questions in the chat if you need to. So the goals for today, we're going to discuss the most common anomalies that we find in data remediation. We're going to understand the impacts of the anomalies as a whole, and how they basically impact NG9-1-1. Because as we know, NG9-1-1 is really changing the GIS profession for people who manage these data sets that are going to be supporting NG9-1-1. We're also going to review some best practices for data management to mitigate the risks and prevent you from introducing error in your data. And then we're also going to learn ways that we can create a quality assurance culture for data integrity. Let's go to the next slide. So this presentation it would be very easy to go down a rabbit hole with you guys and talk about the ways that GIS is actually being used to perform the NG9-1-1 functions, okay? But that's not really the goal of today's presentation. We do have a lot of presentations on actually, but I will tell you that, we do need to have a good understanding of what NG9-1-1 actually is, what's required, and then, we can have additional conversations about what are optional layers or what are strongly recommended layers. But really, we're going to focus on these for the purpose of this presentation. Okay, so road center lines and address points are known as Civic location layers. Okay, so when there's a query that involves a Civic address, an attempt is made to match the address from an originating service provider, it's called an OSP, with a corresponding location based on attributes within the address points. Okay, so the schema for the address points, and for like people who are not very familiar with GIS, when we say schema, we're talking about the way that the data is structured as far as what the attributes look like. The attributes describe each individual feature. Okay, so we call that the schema. The schema supports information exchange in that call process. Okay, and there's an entire NINA document out there. It's called the Civic Location Data Exchange Format document. And it goes into a lot of detail about that information exchange. But the road center lines and the address points are called civic location layers, okay? The PSAP boundary, the provisioning boundary, and then individual emergency service boundaries for fire, law, and EMS, those are called service boundaries, okay? So what they do is they actually show the geographic extent for your different agencies. Okay, so for example, your PSAP boundary is going to show basically the extent of your PSAP, okay, and that is going to be engaged before the call ever comes into your PSAP, that particular data. Okay, so service boundaries are used by the ECRF during routing requests, and they're also used by the LVF to validate whether a given location is routable, and all of that is done with GIS data, okay? You'll kind of hear this over this week, but one of the ways that I like to describe GIS professionals now going into the NG9-1-1 sphere is we are geospatial first responders. Okay, so when I mentioned a couple minutes ago that, you know, NG9-1 is really changing our professions, it's true. And we'll talk a little bit about the ways that our data is changing, but the ways that our data is changing is also really going to dictate the way that we need to change with the data and the way that we're doing things, okay? So let's go to the next slide.
You want to, we have a polling question on this one. Yeah,
sorry.
Let's do the pop quiz.
So let's do a polling question, Steph. All right, so do you currently maintain all of these data sets required for NG9-1? Yes or no? And we'll give you all a second to answer those. And the results should pop up here in a sec, right, Steph? All right. So this is very common, okay? And generally when we're working with our clients on data remediation, a common theme is, well, we don't maintain that. And that's okay, because most of us are not maintaining all of these layers required for NG9-1. Some people only have the road center lines, address points, and you may have like ESEs or ESNs or response zones, you know, you may call them different things. And some of you may start with your jurisdictional boundary to kind of develop your PSAP boundary. And we'll talk a little bit about that later on. So thank you all for participating. We do appreciate it. There's a couple more polling questions. Okay. So one of the things that we like to talk about when we're talking about NG9-1 data is there's really a lot of different facets, right? So a long time ago, NINA had a document, I think it was like 09, that said you have to have a 98% sync rate between your databases. But we know that with GIS, you have the geography and then you have the databases. And really the two together are what make GIS what it is. So the point is that GIS, by virtue of the fact that it introduces the geography, adds many different facets to the way we have to look at our data when we're talking about preparing it for NG9-1-1 and validating it and getting it cleaned up, okay? Yes, you can sync databases, but that's just one piece, okay? So all of these different things then really impact our data. So when we talk about completeness, there's different, I guess, levels of completeness. So number one, do you have all the layers that are required? All the ones that we just saw on that previous slide, are all of them present? Because they have to be. Do you have all of the required fields maintained within those layers? Okay. And we'll talk about that here in a second when we look at the NINA data model. Is all of your GIS data maintained in the layers? Okay. Are you missing address points? What are the implications if you're missing address points? Okay. What are the implications if you're maintaining highways in a separate layer? What does that mean for NG9-1-1? Okay. And then we have to talk about the accuracy. All right. We want to talk about consistent data maintenance, doing the same thing across your data set so that you have consistency. Okay. And then the actual location of features. All right. Some of you might be pulling in, DWGs into your GIS to get parcel lines, okay? And then you might be digitizing your street center lines off of that. But then when you get updated aerial photography, you might find that, gosh, that road is now, 50 feet off from where it's supposed to be. So just looking at the location of features, how you're placing your address points, all of that makes a difference. Okay, so why are attributes important? Well, earlier on, and again, I don't want to make this a conversation about how our GIS data is used specifically for NG9-1-1, but just understand that there is a rhyme and reason to why we have to maintain certain data within our databases, okay? And I guess I'll open this by saying that, for a long time, we've been maintaining our data for different business needs. So, for example, we really saw kind of the creation of GIS coming from planning, because GIS was really used originally for land management. Okay, so many of our data sets started off with planning business needs for planning and zoning. Okay, maybe you have an asset management system. Maybe you're maintaining data for transportation. We've been maintaining our data for many different business needs. Okay, and you may be missing a lot of those required fields. All right, so the whole thing about these attributes is that they support the information exchange during the call process. Okay, and address points are going to effectively take the place of your alley, and then the road center line data is going to take the place of your MSAG. Okay, but the NINA data model really goes in and defines what those required fields are. And you need to make sure that you have all of those fields within your data. It's incredibly important, because if you don't, then you're going to be missing some critical information that's going to be used for that information exchange.
All right, so we can talk a little bit more about the specific attribute issues that we often see in NG9-1-1 data. So like Annie explained, the NINA data model contains information about the fields that are required to maintain for NG9-1-1. Here on the right is a small portion of the road centerline data table within that document, and you'll see the descriptive name and field name, and then this third column here represents whether the field is mandatory, conditional, or optional, and then you have the field type and then the width of that field. So the document provides very specific information to meet those standards. Now, if we're talking about the top issues we see in NG9-1-1 data remediation, at the top of that list has to be missing fields required for these standards. So I know we're in the phase of educating and transitioning to NG9-1-1, so it's important to start getting familiar with the standards and begin to maintain those fields marked mandatory in that data model. Another common issue we come across is inconsistent attribute maintenance. And within the NINA data model, it also outlines the values that are appropriate for each field. Along with this, we often see a lack of standardization within the attributes. A big one is inconsistent abbreviations between features. However, the data model requires values for the directional, post type, unit type to be fully spelled out in mixed case. So as we talk about attribute issues and ensuring consistency, let's not forget the big picture here. And that is to create a common language of information across data sets that supports that data exchange between PSAPs and entities. So I've got an example here. So this top image here, there's some address records that we often see in data. one field being maintained to represent all address number information, and then another field is there to host the street attributes. We can see right away that there are some inconsistencies with the abbreviation of avenue, AV and AVE, and then we have the pre and post directional values existing within the street name string. The second image here are those 5 same address records formatted to NINA standards. So first off, we can see that the address number suffix value was pulled into a separate field, and this satisfies NINA standards that an address number be a whole number within an integer field. And then we also see the pre and post directional values parsed and formatted consistently, as well as the post type values. So when we think about maintaining data integrity, by having the individual parsed fields for the street attributes, it allows for that better quality assurance. Each field contains designated specific information, which allows for a more detailed ability to standardize data. Right. Okay. So speaking of attributes and data quality, don't freak out. I know this looks like a crime scene, but to give some context here, all these red lines are anomalies flagged within our VEP software. They're flagged on fishbone lines, which the fishbones show the relationship between address points and center lines. So they point to where the address is geocoded along the associated road range. So what we see here is the address point along these roads have 2 fishbones, each which is an indicator of an issue within the data. So let's start by evaluating the situation. We see that the house numbers are increasing, going to the north of the segment. To the south, the south-left range starts with 2001 to 2009. So if we look at the northern segment of Skyline Drive here, we see that the from range value on the left side also starts with 2001. So the same issue occurs within the right ranges. That's our confirmed range overlap right there, which is causing those address points to not have that single relationship within a road segment. And nice and pretty here. Let's talk about how we resolve this and the reason behind it. So by adjusting the 2 ranges of that southern segment and the from ranges of the northern segment of Skyline Drive, we've resolved that scary situation. We've ensured that the associated address points now fall within only 1 range along Skyline Drive. This example is pretty straightforward since the segments were consecutive, but imagine if an address point fell within 2 segment ranges that were several miles apart within a county. Think how that may impact response time. So when you go to route a resource, it can cause confusion and delay because the location isn't concrete. You know, with road centerline address ranges, we want to make sure we're maintaining unique ranges between segments per street.
Okay, so why is geometry important? We've already talked about the attributes, but why is the geometry important? Well, we know as GIS practitioners that we want to have sound topology as a best practice for managing our data. We want to make sure that we're not having overshoots and undershoots with our road center lines. We want to make sure that we're not leaving any intentional gaps or overlaps between our boundary information. Because again, boundaries are used for call routing. Okay, so there are some implications if you have topological errors within your data. All right, but accurate geometry is critical for that call routing. Okay, that's why we don't want to have any intentional gaps or overlaps. So really, when you're managing your data for NG9-1-1, you need to be mindful and understand how everything works together. How does having a road that's digitized in the wrong direction affect everything else? And you know, you can see that by a simple fix, you can actually resolve a number of different things in one area. So you really do need to be mindful of that. We need to be very mindful about the fact that our attributes within our data should actually reflect what the data is showing. Okay, so you want to make sure that your segments are broken at intersections and snapped. You want to make sure, and we'll talk about more of that in the best practices, but in general, you want the attributes to reflect the same thing as the geometry. Okay, let's go to the next slide. Okay, so some of the things that we've seen with address points in general, inconsistent placement methods. Now, I will tell you that there's no such thing as wrong, okay? You don't want to let perfection be the enemy of the good. If you have address points, that's good because you're doing a lot better than some people who don't have any address points, okay? But really, we want to have the discussion about accuracy versus precision. And, if you have a 100-acre parcel and you've got an address point to represent a structure there, okay, fine. But having it precise, meaning having it placed on its respective structure, that's the best thing. That's the best practice, okay? So we have seen these different placement methods. We've seen parcel centroids. We've seen address points at the entrance to the property, which is really good for vehicle routing, but not necessarily for NG9-1 because, like I said, what if you get to the property and you get to the entrance, but then you're on a 100-acre parcel with 15 different structures on it, farm property or something, and you don't really know where the emergency is. I've seen it along the property boundary, on the road center line, which I understand some CAD systems require. And then, of course, we've seen it on top of the structure as well. So I would say pick something and stick to it. The blue sky scenario is to place your address points on top of the structures. That's always going to be the most precise for NG9-1-1. But, if you don't have the resources to do this, that can be a long-term goal for you. I would say, choose the things that you can fix first. But the fact that you would have address points to begin with, like I said, you're doing a lot better than some people. So let's go ahead and do our second polling question. So our second polling question is, do you currently have consistent address point placement method? And it's a yes or no. We'll just give you all a couple seconds there. All right. Good. And, if you don't have a consistent placement methodology, then feel free to reach out. We can talk to you about that. I will tell you that NINA does have an informational document. Now, there are NINA standards and there are informational documents. And I need you to understand the difference between either one of those. Informational documents are just for guidance, okay? The site structure address point document is informational, and there's a lot of information, and it really does cover a ton of different scenarios for addressing. And the guidelines, the information is very broad because it wants to allow for people who may not have the resources to maintain such a precise level of data, right? Again, something is better than nothing. So let's go to our second polling question, actually, or our third, but our second for this slide. So do you currently maintain subaddresses? Because that's another thing. So do you currently maintain subaddresses?
Anticipation is killing me. see.
Oh, good.
Wow.
Hey, that's great.
That's better than I expected.
Now, subaddresses are not a required field, okay? But when you think about it from a first responder perspective, it's always going to be very beneficial to understand what is there when you arrive at an emergency. So we can go to the next slide, Becca, and kind of talk about that a little bit. I will tell you that throughout my time in public safety and GIS and, you know, all the strategic planning that I've done, there's two major things that I see that are just kind of like nationwide. Number one is mismanagement of subaddresses. And number two is dealing with municipalities as far as them being their own addressing authorities and not communicating that information back to their county, okay, which is a really big deal too, because then you're talking about missing data. But as far as the subaddresses are concerned, we've seen so much. Not only is there inconsistent placement or management, there might be no management at all. And that's okay, because again, it can be very resource intensive. The NINA data model actually allows for subaddress management down to the seat level. Think about that, down to the seat. Now, a lot of you might be super pumped about that because it is very valuable data. It's extremely valuable, but it is incredibly resource intensive to have to send somebody out, collect that data, you know, and then somehow have to keep that data maintained and updated. I think it's a wonderful thing to have, but I think if you're going to plan to maintain down to that level, you're going to need to have some type of plan in place to determine how that's going to stay updated. Okay. That's one of the reasons why when I was in local government, we never managed business names as part of our addressing data, because businesses come and go. And, you know, it just changes so quickly. We may not always be aware of how much those are changing. Sometimes we see stacked address points for subaddresses. We see one point for many structures, as you can see. Now, again, there's not necessarily a right or wrong way. I personally would not do this example because, again, I feel like it's not going to be very descriptive for first responders. And we have to start looking at our GIS data through a public safety lens and understand its use and purpose and business need when we start making these decisions. Okay, for planning, this might be perfectly fine. Okay, but remember, your GIS data is now being used for mission critical activity, okay, which is routing and validating calls, okay, and locations. So we need to understand what that means for our addressing data and for the way that we're placing it, okay? This is permitted, but is it the best thing? Maybe not, because it's not very descriptive about what each individual building is and what's inside of each one. Just some additional things to think about, not that you need it anymore.
All right, so let's talk about some road centerline geometry issues that we encounter. As Annie explained, topology is incredibly important within GIS data. It literally means that spatial relationship between features. And within NG9-1-1 data, especially, we need to be mindful of how one data set can impact another, this holistic view. So some of the most common road centerline geometry issues that we often see are roads not being snapped or split on at intersections. Another situation we often see are roads not split at boundaries. This is not only a requirement for NG9-1-1, but can really impact data in the systems that data supports. We also commonly see incorrect digitized direction of road centerlines. So I'm gonna get into a couple examples here so we can walk through. So if roads aren't split at intersections, you won't be able to get accurate vehicle routing information. It won't be recognized as an intersection. And the example on the left here contains snapping issues at intersections. Not having road centerlines properly snapped at traversable intersections will cause misroutes in emergency locations and could potentially add seconds or even minutes to critical response calls where every second counts. And, whether it's a road centerline segment overshooting, as seen in the top right intersection, or undershooting, as seen in the bottom left example, all of these can impact response time, and it's essential that these geometry issues be found and resolved. So if we're thinking about a highway overpass, that segment can be left unsplit where the roads intersect. That way the data provides accurate representation of the real world. And if the road were to be split at an overpass, there are additional fields within the data model that help support, provide context around that situation. Some of them being elevation, the one-way fields. And the beauty of GIS data is that we're able to minimize workflow impacts when we use a single data set for multiple business needs. So let's go to this example on the right here. This shows a center line that needs to be split at a boundary. So I first want us to think about how this can impact the attributes of the features associated with the address points here. So when a road crosses a boundary, there would be a change of attribution. There should be a change of attribution. If these are incorporated city boundaries, this would cause those three address points here on the right to not be properly found within that center line if the center line is attributed for the left city. So instead, it would need to be broken at that yellow circle right there, right along that boundary, and then have the attributes updated within the segment to reflect the boundary that all of that data is contained within. Attributes of roads, center lines, and address points are used for location validation, and boundaries are used for call routing. So it's important for NG9-1-1 data to reflect the real world. And this data is replacing the MSAG and ALI, like Annie mentioned. So GIS data needs to be able to perform those functions. Continue to think about how important routing is for public safety. Consider if these boundaries represented, fire response areas. That conflicting information between the address points, road center lines, and emergency service boundaries could slow response times due to the need to determine which agency should respond there. And I know we're going to go in a little more detail later on about some of the boundary topology issues. But let's go on to another example, which is this digitized direction. So again, those red lines represent anomalies in the data found within validations. And so I always like to start by assessing the situation. We can see here that the endpoints of those road center lines meet, which is a first indicator. And then as we assess the associated address points, we see that they don't fall within the correct range values of the right and left sides of the road. So this causes those address points to appear on the wrong side. And when we think about digitizing a road, we want to have the line endpoint be digitized in the direction of increasing address numbers. So in this situation, because the road is pointing to the south, which is the opposite direction of the address number values, the address points can appear to be out of order and on the wrong side. All right, so let's go to how we resolve this situation. To resolve, we can flip the road segment direction to now be digitized in the direction of increasing address values. So this now, by that one geometry fix, we've now resolved all of those other apparent issues with the address points being out of order and on the wrong side of the segment. And when you first look at a situation like that, the data tells a story, right? And what we're trying to get you here is to think about how data is correlated, how it plays off of one another. So by that one geometry fix of the center line, we were able to resolve a lot of those other issues that were seemingly visible. So for a data consistency standpoint, this is important, right? But let's now think about how this road center line, if it was along a boundary edge, we would need to have the correct side of the road attributed with the proper information to support proper call routing and agency response. So if agency A was on the right side of the center line and agency B was on the left side of the center line, and if it was flipped indicating incorrect attributes on the sides, agency A would show up instead of agency B. So, and Annie's going to provide a little bit more about that right now.
Before we move on to the next slide, though, go back one back. I wanted to point out something that you said, that the data does tell a story, okay? But more importantly, and really going along with that, the data is solving problems for us, and they happen to be life mission critical problems. So you have to have consistent, no pressure, y'all. Everything that you're maintaining needs to be consistent. So when somebody comes to me and says, man, you know, I really don't want to break my road center lines at the boundaries, like, do I really have to do that? You do, because you need to make sure that the data, because remember, it's looking at the attributes, but it's also looking at the geography as well. So you want to make sure that all of that information among those different data sets is consistent. So I just wanted to drive that point home. All right. And we do have some really good questions that are coming in, and we are going to answer those for you guys. But let me go ahead and talk about my personal favorite topic. Could you sense my enthusiasm there? Boundary geometry issues. Guys, for those of you who don't know, I manage all of our boundary facilitation workshops for DATAMARK. So I work with all of our clients to really sit with their neighbors and resolve boundary issues, and I also lead all the strategic planning stuff. So I have so much information surrounding this entire topic. We could really have like an all-day workshop about this. But common issues that we see with boundaries: number one, that not all the data is being maintained. Okay, so a lot of y'all are missing the required ESBs, but guess what? That's because you've never really had to maintain them before. It's not like it's you know, this terrible thing that you don't have them. They're easy enough to create if you have ESNs or ESZs. Okay, especially if your ESNs and ESCs define your service area, you can generate what's called a first pass. Similarly, the provisioning boundary. Your provisioning boundary is kind of like a geofence around the area that you all are responsible for, okay, as far as the GIS data maintenance. And as is true for all of our boundary data, gaps and overlaps. To understand why this is a big deal, you need to understand what the boundaries are actually doing for the 911 process, okay? The boundaries are used for emergency call routing, all right? So your GIS data, your boundary is actually being used before the call ever comes into the PSAP, okay? And it's done using a spatial query. It's a point and polygon analysis, either using a Civic location, like an actual a physical address, or geodetic with lat-long coordinates in the case of like a mobile device. Now that's a different process, okay, but I'm just this very high level again, okay? So, you know, you have to understand that it goes between, it's more than just, okay, we need to resolve this gap or this overlap. It requires a little bit more thought. So let me go to the next slide. And really, this is a perfect example of what I see when people give me their data, especially if the topology is not congruent. And when we say congruent, we're meaning they fit together like piece of a puzzle. There's no intentional gaps or overlaps, because if there are, what'll happen is it'll go to default routing. And do you really want a machine making that decision for you? A mission critical, a life critical event? Do you want a machine default routing your call to one PSAP or the other? See, the goal with NG9-1-1, one of the many goals, is to minimize transfers between PSAPs. that's kind of a big deal right now. You hear these calls being transferred numerous times. So that's why it's so important to have these boundaries correct. Now, GIS people, let me tell you something. And I know this is going to be hard to hear, okay? But you all don't have any business making these decisions. I know, I'll just let it sink in for a minute. You can, say all your bad words and stuff when you're on mute, that's fine. But I'll tell you why, okay? Because as GIS people, all we care about is where to draw the line. You tell me where you want that line to go, I'll draw it for you, that's fine, okay? But these are not just boundaries to make a pretty picture. These are boundaries that are making critical decisions. So when you're talking about developing boundaries for NG9-1 call routing, you absolutely have to engage your PSAP staff. You must engage those people because they are the ones who have the boots on the ground knowledge of the area. They are the ones who intimately know, or we hope they know, their MSAG. Okay, and if they can trust their MSAG, they can actually use it to help make those decisions about that physical boundary. Okay, so any data that you create, so for example, we have a lot of people who will take the, like county jurisdictional boundary and they'll do a copy paste and they'll use that as like a first pass, what we would call a first pass, meaning like a draft, a first pass like PSAP boundary. Okay, and that's not a bad thing, but you have to understand that a jurisdictional boundary is a totally different boundary than what's used for call routing. You can't like just willy-nilly change a jurisdictional boundary, right? It's platted, it's a legal boundary, it's a judicial boundary. A call routing boundary is for call routing. Okay, so wherever that line is drawn is where the bounds of that call routing boundary are. That's the point. That's the fundamental difference. So it's not bad to use that. I mean, we do that all the time as part of our normal workflow, but that's only a first pass. And you should make sure that you're meeting with your PSAP staff to talk about, hey, is this the best location for this boundary? You guys really need to approve this boundary because this is going to be used for call routing in the future. So, when we think about an address point that falls in a gap, again, it's a call routing boundary. So if you're in that little point in that gap, then what's going to happen when you call 911? All right, so let's go to the next slide. Okay, so we need to be proactive with our GIS data, obviously. We want to make sure that we're not, kind of like waiting for the problems to catch up to us, okay? And I will tell you that as part of the strategic planning process, one of the things that we talk about all the time is the fact that GIS data, getting that ready, is the biggest part of any NG9-1-1 deployment. It's not in the hardware, software, call taking equipment. It's always in the GIS data. Why? Because like we talked about already, our GIS data has been used for different business needs in the past. Okay, so it might be ways away from where it needs to be. Also because we're just not used to having GIS data formatted. We're not thinking about it from a public safety perspective. Okay, so we need to make sure that we're very heavily engaged to be proactive with validating and QCing our data. We need to use best practices for addressing and road centerline workflows, and also for data management. Okay, and that involves creating a quality assurance culture. And this is our last polling question, so let's go ahead and bring that up. Do you currently incorporate any QA into your GIS data management workflows?
My dog is snoring in the background. I think we're boring her.
That's okay. I'm happy that I haven't like machine gun sneezed because it's a nice day here in Virginia today, y'all. And I opened my window and the pollen just came in and took my soul. So I'm trying so hard to just keep it good for y'all, but I'm trying not to sneeze.
All right, we're almost done. Just contain yourself, all right?
I'm trying. All right. Okay. So we do have about 73% of people, and, you know, we could have a much larger discussion about what that quality assurance looks like. But just say for NG9-1, it has to be very comprehensive. Okay. You have to really continually validate your GIS data against different attribute and geography checks to make sure that it's meeting everything that's required. Okay. So thank you guys for participating in that. That was our last polling question. So let's go to the next slide, Becca. Oh, you're already there.
Right. Yeah, way ahead of you. So let's talk these best practices for NG9-1-1 data management. The common theme here during this whole presentation is maintaining those required fields within the data. And I do believe that this is the best first step we can all take towards NG9-1-1 data readiness. It's just becoming familiar with those standards and to start implementing the maintenance of those required fields within the data. So, let's continue to see the big picture. Let's be mindful of how other features within a data set can impact one another. So if we add in address points within our master data set, as we're doing that, we need to be thinking about the associated road centerline ranges and whether those address points, the ones that we're adding in, are going to be represented in that range. And same with location, right? So if not, we need to be sure to adjust them. Also, as we discussed, we want all the data that is encompassed within a boundary to have those appropriate correlated attributes to that polygon. So when roads get split along boundary edges, we need to make sure we pay attention to those attributes as well. So it's kind of just that forward thinking, getting that big picture. So parsing address elements, it allows for a more fine-tuned approach to data consistency. So with fields separated as individual components of data, say street post types, it's easier to sift through and ensure that standardization. When one field contains a concatenated full address, it can be difficult to pick out those separate components to standardize. I think it's always a best practice to maintain individualized data fields and then build upon them instead of the alternative. It's easier to concatenate than to pull out pieces within a string of data. Another best practice with standardizing those attributes is leveraging domain values. This allows you to control which values will exist within a field and then really help eliminate that potential for human error and those fat fingers that get wild sometimes. I mean, we're all human, we do it, right? So domains are great to implement, especially with next gen standards. So one final best practice here, I like to point this out, is to avoid blank values within your data and replacing those with nulls. So blanks can cause those unnecessary discrepancies across records and layers, and it can cause issues with validations. I mean, it's seen as a value. So replacing those with nulls is just as a GIS person, a best practice. I think, yeah, that's just a general GIS best practice. So as you continue to maintain your data, just be mindful of that big picture. Like Annie mentioned, be proactive, not reactive. So if we're being proactive, we can kind of spot those issues that might come from some of the manipulations we're making in our data.
Okay, so some information about creating a quality assurance culture. Number one, enforce those best practices. Make sure that you are following best practices for your addressing, for your road centerline workflows, for your GIS data management. A lot of this does kind of tie into strategic planning. If you suspect that you have issues in your addressing workflow and you're trying to identify those, you may want to look into doing some type of strategic plan, because that's when you can really dig in and understand that entire workflow process for assigning an address. So, if you're missing chunks of information, why is this happening? Why am I not getting the information that I need? So it's very helpful to go through that effort to understand who your stakeholders are, bring everybody to the table, understand the different business needs for the GIS data, who's been managing it and what is it being used for, educating those stakeholders about NG9-1-1. What are the implications when you have someone who's in the planning department assigning addresses with no regard for public safety? I've seen that before, and it's problematic. Okay, working on improving those existing workflows, that's also extremely important. Identifying any choke points along that process.
And this last one, that iterative validations, I really want to stress this because I think it's so important, especially with NG9-1-1 data. We need to think of data maintenance as an iterative process. It's not a one and done situation. So every time a new feature is added or attributes are edited, we could potentially be causing errors. And by being mindful of how data impacts one another, we can catch a lot of those updates. And, like I said, let's be real, we're all human, mistakes happen. So unfortunately, mistakes in data when associated with NG9-1-1 can be critical. So implementing a routine validation and, scheduled maintenance is really important for that quality assurance.
Yeah, and I just wanted to close by saying, NG9-1-1 is really changing the landscape of what it means to be a GIS professional in this world, within local government, within state government, anywhere you're maintaining. And we really need to be mindful of the fact that, this is critical data, and your data is going to be asked to do something that it's never had to do before, with an accuracy and completeness that it's never had to have before. So, I will say that I know GIS people were very proud of our data. We take a lot of pride in the quality of our data. So, it is good for you to just reach out for an assessment of your data if you've never had one before, or find some way to have that assessment done. We can do that for you, but other places do it too. But I'm just saying, based on what we've done, we have seen so many people drastically improve their data by just understanding where you're lacking to begin with, because a lot of times you don't know where you're going if you don't know where you're beginning. So that's kind of the thing. Okay, so we have a few minutes for questions. So Aaron asks that about being concerned about address points being overloaded with too many attributes. Yes. So we do see it different ways as part of the strategic planning process. We do understand how people are maintaining the databases and how they're maintaining data for different business needs. So we've actually seen it a couple of different ways. Some people will, for a lack of a sophisticated word, they'll Frankenstein their schemas together. They'll say, okay, well, I'm just missing these 5 fields that are required for the NINA standard. I'm just gonna mesh those in with my other fields. Other people have developed an ETL process, which just extracts those fields that are required for NG9-1-1. It really just depends on how you guys want to manage your data. You have to be mindful of what business needs your data is already supporting to determine if that's something that you want to do. So thank you for that question. Just found out that Microsoft released and updated the nationwide building outline features. Hey, that's a pretty cool link. So thank you for posting that, Charlene. If you guys want to check that out, there's a link there in the Q&A. And Becca should there be an intersection at a highway on ramp or off ramp? Should we do that as part of a best management practice for data maintenance? Yeah,
so that highway off ramp on ramp is going to be connecting to another intersecting road on that same elevation. It's important to depict that actual intersection in the real world. The example that I gave of the highway overpass, that was when the highway, it's going to be, you physically cannot drive up to a highway overpass, right? You're going to be going underneath. So that's where it's appropriate to leave it unsplit in the event that you don't maintain the other, the fields that can provide context around that situation.
Okay, thank you, Becca. So what level of subaddressing is needed in the future NG9-1-1? As far as like MLTS, which is multiple phone line telephone systems. I think that's right. I probably got that wrong. But anyway, you can, so again, the NINA data model allows for subaddressing down to the seat level. It is an optional field. So, you know, if you already are maintaining subaddresses, then keep doing that, but you don't have to maintain to the seat level. If you want to maintain to the seat level and, you know, associate phone extensions within a cubicle and give it an address, there's nothing wrong with that. That's actually, I mean, that's extremely precise. But, you know, again, you have to consider your resources. So, so I hope that helped, Brian. And if you want, you can always reach out to us. That's totally fine. And then a centerline splitting at boundaries, when the boundary is not accurate or may not be accurate, how do we evaluate where to split at an uncertain boundary? Becca, I'll let you take that one.
You know, I think there's kind of an order of operations with dealing with data. You're only as good as what you're working with, right? So I would strongly encourage you to, if you're not confident in those boundaries, you know, that's going to be your first step, right? We need to get those to be accurate. You know, the road, like splitting the road along that boundary is really to maintain those appropriate attribute information. But for call routing, the boundary is what really dictates that, right? So we need to make sure that those boundaries are sound. I'm not sure if that answered the question. Maybe Annie, if you have more to say, but I think it's really getting those boundaries to be where they need to be and then going through the process of updating.
Yeah, you know, I agree. And this has been my experience with boundary stuff. You really should solidify those boundaries first. And then make sure that, you know, those are where they need to be, and then do your road remediation. Otherwise, you're just going to be kind of remediating the data twice. And that's a very, very common scenario that we face.
I was just going to say that. Yep.
Yeah. So we're almost at time, but we'll do, how do you handle an address range increasing on the left side of the road, but decreases on the right side, coming from an older road?
Love it. Love the question. So, you know, data represents a real world situation, and in that there are exceptions. You're not always going to have the perfect scenario. So if you see that the left side and right side are conflicting with the way the addresses are increasing or decreasing, depending on what you're using, that can be marked as, you know, an exception, because it reflects what's happening in the real world. So there's really no change that would need to be made to that road, because either way you flip it, there's going to be some issues, right, or apparent issues, but it's really not an issue because that's how it is in the real world. So again, the data tells the story. If you have an ability to mark that as an exception in your data, then that's what I would suggest.
Yeah. Well, we are right at 2 o'clock Eastern. So unfortunately, we can't answer all the questions, but we will do our best to follow up with people individually to make sure that we can address your questions. So just want to say thank you all so much for participating in this and answering our polling questions and asking really great questions. We appreciate each and every one of you and wish you a wonderful week here at the virtual conference, and reach out if y'all need anything. Thank you.
Yeah. Thank you, everyone.